Signs, ISC squared are in fact not for profit, as I'd like you to have you believe. But the important thing to remember is from these two sorts of sectors of the community, how many people of these have actually found security vulnerabilities within applications themselves? The answer was best summarised by Thomas Pci from Minnesota, which was 5% of vulnerability, 95% of SISPs discover 5% of the vulnerabilities. So once we've looked at the operator, we can then start looking at the scoping issues and mapping the attack surface from there. So what's really out of scope? Well, anything that basically involves the person having to implement or having previously implemented the PCI data security standard and their resulting effort around those standards and their continued performance and all that kind of thing. So really what's out of scope? Single implementations, which are simply custom development payment application software. You don't have to have that reviewed. Payment gateways aren't covered because they're covered under PCI-DSS, and your implementation also isn't covered based on the fact that if it's a database or an operating system. The main reason again being is that they're covered under the PCI-DSS. So essentially that means we have to look at exploiting the attack surface of that standard. Now, in scope is payment applications which process Visa only. Again, the reason I state Visa only is because Visa are the only card brand that mandated it. And what we actually have to look at is only the payment module within the commercial off-the-shelf program. So our attack surface then is really on the other modules as well as any sort of third-party libraries that it relies on and that kind of thing. So those are our sort of two attack vectors for the scoping. Okay, what I've done now is I've highlighted up the top where there's a PCI dependency. So I'll go through all 14 or whatever it is of the standard itself fairly quickly. So what we have here is the one that's lifted pretty much from PCI-DSS, which is we don't maintain any information on the actual credit card itself related to the primary accounts info. So we have really dumb and stupid things that come out of sort of the Osaka SIS community, which is if you mask on the screen the credit card number using sort of asterisks or that kind of thing, you can still read it within memory of the device driver itself. We also have a lot of commodity hardware which is used for payment applications. Now by commodity hardware I mean not restricted. So it's not like you're buying a PIN terminal that comes automatically configured and is tamper-proof and all that kind of thing. Okay, to protect stored credit card data, again this is taken from 3.4 of the PCI data security standard. Within those cryptographic specifications, they don't actually specify modes, the approved modes of cryptography. They specify the key size and the cryptographic algorithm you can use. So what you find is people using really dumb and stupid modes like ECB. The possible root cause of this is people largely citing Bruce Schneider's text apply cryptography as a reference for all sort of crypto work. So hence that's why Bruce has actually had a lot of trouble sort of getting too fictional and accepted by the crypto communities because basically they dislike him now, more or less due to his popularity also. Okay. In relation to one that's specific to the Payment Application Data Security Standard, number 5, develop secure payment applications. It cites the OS guide. There's no actual state publication released by OS referred to as the OS guide. OS publish a number of different publications. What they're actually referring to is the top 10. We're currently in the process, myself, Dave, and everyone sort of else within the community that's on the mailing list there, going through the release candidate for 2010. It was meant to be published now, but because of some of the issues that have been raised, the publication's been delayed slightly. The problem with this and using the OS guide is the OS is specifically related to web applications. All payment applications, or a majority, are based on 10 and mainframe or AS400. So really, the only thing that Darren and I could think of when we were putting this presentation together was that they must be referring to a web server running on an LPAR on either a 10 and mainframe or AS400. Now, so really using the OS Top 10 guide to basically look at a payment application is probably the wrong way of looking at the methodology. In the end, Myatt, by their CVE database have over sort of 700 types of vulnerabilities, that's probably what you should actually be looking at and focusing on. Now, with version 6, we still have the same misunderstandings in relation to wireless coming from the PCI Security Standards Council. So WEP is still in there. It is being phased out. You have to use WPA now for all new implementations, with WEP sort of having a sunset clause on it. However, it's interesting that the PCI Security Standards Council claim that they actually listen to the community and then modify the standards from there. So one of the original PCI controls within version 1 was to turn off broadcasting your wireless SSID, which is just wireless network name. Joshua contacted them back when they published the first version. They published 1.1, there was no change. It wasn't until 1.2 that they actually came around with a change. Now, if you look at their life cycle, which is, I think, 2 to 4 years, that's quite a significant, actually it's 2 years, sorry, that's quite a significant time to actually turn around and remove sort of stupid controls that don't actually add any security. Because as most people know here, you can find the SSID just as soon as someone connects to it, or broadcasters that are intending to connect via sort of an auto-connectable wireless client. Test payment applications to address vulnerabilities. This isn't actually the correct way of actually addressing the vulnerabilities. What you want to do is focus more on the maturity of the software development, not at a specific point in time and doing more about SEC review or pen testing. So really, if you address vulnerabilities at the end of the software life cycle, you'll find that they'll still ship the product. They just expect that people won't publish them, and then they'll remediate them as they're discovered by the community itself. Okay, PCI has secure remote software updates, and this has been reflected in the payment application one also, as their requirement 10. Secure software, remote software updates are a very nice feature, but and they can be implemented, and they have thought of things such as the chain and all that kind of thing, chain of trust. Obviously, they haven't mandated code signing for some reason within the payment application itself, so it makes sure that it loads something up. So what you'll actually find is you'll have the evil grade the vulnerabilities that evil grade uses to essentially insert arbitrary code into the payment application itself. Now, what these can be is, if you control the network, you can do ARP spoofing, DNS cache poisoning, DHCP spoofing, etc. Okay, the final two, which are basically encrypt sensitive data and console access. SSL is still largely considered the sort of solution by the PCI Security Standards Council to do this. SSH sort of comes in second, and then you've got what they just IPsec VPNs, which they just refer to as VPNs. But the problem is that when the standard was published, they haven't now considered all the recent attacks against SSL. So really, they need to be included in or considered as part of the implementation.
Okay. We are gone. Going. Yeah.
So just in summary, I more or less base a lot of these statements on the Australian or my Australian experience. Really what we find in Australia is financial security is really just nothing more than smoke and mirrors. There's 3 banks in Australia now, major banks. The CISOs of all of them generally just form their own empires below them. Some of them sort of go up to 100 people. And the problem is that because we have this sort of big empire below them, their egos and all that are sort of compounded by people blowing smoke up their arse. We don't find this specific to the Australian financial sector, so we find sort of our intelligence defence services, which like to be portrayed as Hollywood, really aren't. We find in our big 4, we don't really have big consultancies in Australia, or sort of, really sort of, or we have prominent people, but they don't work for consultancies as they do in the US, so they tend to work individually. And critical infrastructure is also becoming sort of elitist in this way. For the final slide, the other problem in relation to why the payment application data security standard is in this thing is more or less we have people tend to hit